Good afternoon, good morning, good evening, maybe even good night, everybody. My name is Mark de Gouw. I'll be moderating this session. I'll be looking at the chat and the Q&A in Whova. And we're going to listen to Dan Gottlieb, who will be speaking about bulk data, an interesting and most certainly complex subject. So Daniel, go ahead, please.
Great, thanks, Mark. Let me just share my screen. Present. All right, great. So let me know if folks can't see my screen, but you should be seeing the slides now. So as Mark said, my name is Dan Gottlieb. I run a small consulting firm called Central Square Solutions, focused on helping organizations adopt FHIR to improve clinical care and research. And today I'm going to talk about the FHIR Bulk Data API, which is a project that myself and many members of the FHIR community have been working on for a couple of years to make FHIR work better for transmitting large data sets, population level data sets. And we'll talk a little bit about kind of what that means. Also, I dropped the URL for the slides into the chat. So if you want to follow along, or if we skip some slides in the interest of time and you want to go back and kind of dig into those topics again, the slides are posted on the internet. So a little background about me. I'm going to skip that again. That's one of those things, if you're interested, you can look at. The slide URL is also at the top right of the slide. So in this session, we want to cover a lot of things. So we want to talk about what is the FHIR Bulk API and why it's needed. Talk about a little bit about the technical architecture. This is DevDays, so we're going to dig into kind of the requests and response in some detail. I want to talk about some great open source tools that are now available to when you start to develop servers or clients that use this bulk data API. Talk through some implementations that have started to appear supporting the API. We've spent the last year in the Argonaut FHIR Accelerator building some of what we learned from those early implementations back into the spec. And so there's a draft version 1.5 of the spec, and we'll talk a little bit about what changed and what's new. And then lastly, we'll talk about kind of where the project's going and how you can get involved and how you can use it. So kind of a crazy packed agenda for 40 minutes. So I'm going to try to get through all of it and still have some time left for questions. So when I think about kind of population, when I think about clinical data, I often think of like 3 levels of data. So at the first level, you'd have like single patient data. And so if you can kind of imagine if you were a clinician seeing a patient, you might have a clinical calculator embedded in your EHR, maybe a smart on FHIR app that's calculating that individual patient's risk. And so for those types of applications, the FHIR REST API, the regular FHIR API, works really well. It's kind of, that's the sweet spot for kind of pulling down a patient's data. It happens very efficiently. You have a lot of options, and that's great. When you start to get into panel level data, so imagine like a clinician who wants to look at like which patients have upcoming appointments over the next month. So you're pulling down data on a bunch of patients. That works through the FHIR API, but you have to be a little bit careful about managing the size of the data. So doing things like using the FHIR underscore elements parameter to restrict the fields that come back, or paging your data to only pull down a subset of the data at a time. So it starts to get a little bit more complicated to use the FHIR REST API, but it certainly works fine. Where that starts to break down is when you start to get into population level data. So let's say you want to move data from an EHR into a care management system. And so you're moving data on hundreds, thousands, maybe even millions of patients. And so that could even be billions of FHIR resources. And at that point, the FHIR API doesn't really fit that use case. And that's where this FHIR Bulk Data API that we've been working on fits in. And there are a lot of use cases where you want to move data on these large populations of patients. I won't go through all of these in the interest of time, but I wanted to highlight a couple that have been pretty relevant to work I've been doing. A really common use case at many healthcare institutions is to move data from maybe one or more EHRs into, and maybe some patient-reported outcome measures from a different system into a combined data warehouse for things like research study, cohort identification, or calculating quality measures. So you want to kind of consolidate all your data. And the way this is done often today is you do like comma delimited exports, CSV file exports from all these different systems. You run them through some sort of transform using some job management software, and then you load them into your data warehouse. And this works, but it's a little bit brittle. If your data warehouse schema changes or the EHR source schema changes, you have to kind of modify your ETL scripts, modify the scripts that are doing these transformations each time. And it's also different at each institution. So depending on how you're kicking off these jobs and managing them, every institution might have its own authentication mechanisms, its own mechanisms for managing the jobs, things like that. Another example that comes up pretty often is needing large data sets for machine learning. And I worked with a startup that actually had developed a risk prediction model, and they were contracted with a provider group to apply the model to their patient population. So they wanted to tune the model using data from this particular provider group. And so to get the data, this provider group actually had a cloud-based EHR that supported FHIR. But to get the data, because they were using the regular FHIR REST API, the startup realized that the patient IDs in this EHR were sequential. And so they kind of looped through and tried every patient ID and then made requests for each type of data, each type of FHIR resource for that ID, kind of walking through the paging. So it worked, but it involved hundreds of thousands of API requests and was kind of a very slow process with a lot of failures. And they mentioned to me that they were kind of terrified of when they have to do this again to update their model again. So even with FHIR data, when you start to need data on all patients in the system, it becomes a little bit cumbersome. The third example I wanted to highlight is around pulling, it's not around EHR data, it's around pulling data from payers. So in this case, healthcare claims data into the EHR. And so the use case here might be if you're a provider organization and you want to see if your high-risk patients have gotten flu shots yet, but patients can get flu shots in many places, at least in the US, you can get them in pharmacies. And so those will show up as claims to the payer, but the healthcare provider might not know that the patient has received those flu shots. So in this case, they would want to be able to pull down a set of FHIR claims or explanation of benefit resources into their EHR so that they can surface that data when they look at the patient. And this is actually a use case that the government payer in the United States is supporting, and we'll talk a little bit about that when we talk about implementations. And there are many other use cases where you need to move data on a population of patients. And so the goal of the FHIR Bulk Data API is to say, can we take these building blocks of FHIR that have had an incredible amount of work over many, many years by a very large community and put them together in a slightly different way to work better for these large data set use cases. So can we use FHIR resources as the standard data model so that we're not kind of always mapping fields from one system to another? Can we say everything is just FHIR and we're just going to use that as the core data model? Can we use the FHIR operations API to initiate the data extracts and manage the jobs? So again, this wouldn't be done differently in every system, but we could use the standard FHIR API to manage the process. And lastly, can we use smart backend services authentication and OAuth-based security model for authentication and authorization so that this is standard and you can build a client once and run it against a bunch of different systems that support the bulk data API. I'm not going to talk about what's out of scope, except to say that the FHIR Bulk Data API is really a technical API around data transfer. And so other ancillary things like legal agreements, can you actually view this data, or kind of pipeline type of things, how do you transform this data in terms of matching patients, things like that, are outside of this spec, but can be done kind of in conjunction with it. And we can get into some of those limitations a little bit more in the Q&A, and certainly look back at the slides if you're interested. But I wanted to shift gears a little bit because this is DevDays and dig into kind of the details of how this API works. And so it starts with what's known as a kickoff request. So here on the screen, you're seeing the blue box on the left is the bulk data client. So this is the system that's going to be receiving the bulk FHIR data. So, even though we're saying client, probably this is maybe a nightly cron job that runs on a server and pulls down all the data that's been updated since the last day. That's like a very common pattern for pulling down population level data. And then on the right, we have the bulk data server. So this might be an EHR system. It might be a payor organization that has claims data, or it might be even a data warehouse, care management system, lots of systems that are serving as bulk data servers. So this kickoff request is asynchronous. So that's kind of the first thing I wanted to mention. So if you're used to the regular FHIR API where you make a request and get back some data, this is a little bit different because here we're talking about what are potentially very large data sets. And so it might take the server a little bit of time to pull together that data or to mutate it in some way as it's exporting it. So instead, what you're doing here is you're kicking off a job. You're starting this export request. Then you can check the status of the job, and then when the job is done, you can download the data. So there's like several more steps than you might expect from the FHIR REST API. So getting back to the kickoff request, there's 3 types of requests you can make. The first is a request for all data on all patients in the system. So this is /patient/ $export. The $ is how FHIR designates an operation request. And so that'll pull down data on all patients in the system that the requester has access to. So that's kind of an important point. If you don't have access set up for the system that's requesting the data to view certain patients, those won't come back even though you're requesting all patients. And this is similar to the way smart on FHIR apps work in terms of data security. And then the second type of operation is maybe the most common one in production today, which is pulling all data on a group of patients. And so these groups are defined using the regular FHIR groups API. So FHIR has a resource type of group that can define a set of patients. And in bulk data, we leverage that and say, okay, you've defined a group somehow. Maybe you've used the FHIR API to do it. Maybe you've done it in the EHR, by picking patients for a research cohort. Maybe you've defined this group dynamically. So it's all groups who are members, all patients who are members of a particular payor, or all patients who are diabetic. However you've defined this group, you can query the group's resource and get an ID for that group, and then you can export data on all the patients in that group. So here we're exporting data on patients for a specific one group at a time and getting just those patients' data. The third type of operation is at the root level of the server, and this is to export all data in the server. And at first glance, this might look similar to the first request on all data on all patients. The distinction is that there's some data in a FHIR server potentially that might not be tied to a patient. So if you think of things like value sets, where they're not directly associated with the patient, but you might want to export them if, for example, you're moving your data from one FHIR server to another, or you're doing a backup. And so this third type of request supports those use cases. There's also a number of parameters that you can put on these requests. The first is a parameter called output format. And this is the format that the data that's being exported will be exported into. So the format that the client will receive. And according to the spec, kind of all servers and clients have to support a format called NDJSON. And we'll talk about what that looks like in just a bit. It's a very simple text-based format. However, servers can also support other formats optionally. So a server might want to support a format like Parquet that's binary and optimized for analytics. And as long as the server supports that format and the client wants that format, it can request these alternate formats using the output format parameter. The next parameter is called _since. And this is a really important parameter for many common use cases. It lets you filter to only get results that have been modified, FHIR resources that have been modified after a particular date, after a particular timestamp. And so you can imagine if you're pulling data on a nightly basis from one system, you might use the _since parameter to only get data that's changed since the last time you pulled data successfully. The third parameter type is _type. This filters the results to limit it to only certain FHIR resource types. So if you had a downstream system that only needed, for example, lab results, but not patient conditions, you could specify an _type of only observation. And so you'd only get those FHIR resources that have lab results in them. And then the fourth parameter is called type filter. And that's an experimental parameter, so only a couple servers support it today, but that lets you apply far more granular filtering on the server. So you can actually use the filter parameters from the FHIR REST API as part of your bulk data export. The alternative, which other systems are doing today, is to kind of have the clients pull down slightly more data than they need, and then kind of filter it on the client side to keep the server side export simpler for systems that weren't necessarily designed with advanced FHIR filtering in them. So we've now made our kickoff request, and what you get back, remember, we're not getting data back yet. We get back a content location, a URL to query about this job. And so that'll look something like this. We'll get back HTTP status of 202 accepted, and we'll get back a content location, which is the URL we can use to manage the job. So let's say we ping that content location from our client. Here's what we'll get back is a current status of this job. And so here we can see there's kind of two useful status parameters. One is, these all show up in the response header. One is X progress, and this is a text-based parameter that the server can supply to the client to kind of say where it is in the job. And this is going to differ by server based on kind of what information that server is able to provide. So some servers will be able to say something like, in this example, 50% complete, meaning that we're halfway through generating your bulk data export files. Other servers may say things like, 100 out of 1,000 resources generated, or if a server is, sent the job to an offline process, it might be something like, in progress. So this is useful for maybe logging or debugging, to kind of have that kind of status information for the client. There's also a retry after header that servers can optionally provide. And this gives a hint to the client as to like how long to wait before polling for status again. So in this case, the server is telling us to retry after 120 seconds, so after 2 minutes, to see the status. And of course, you can poll as much as you want as a client. There's no harm. You would just get back a different status like this. But of course, we don't want clients to hammer servers, and clients don't want to make unnecessary requests. So this provides some hints in that regard. So let's say we wait our 2 minutes because we're a well-behaved client, and then we hit that content location again. If the job is completed now, we'll get back a complete status, which will come with a JSON manifest. So this is what the complete status response body looks like. Let's go through some of these fields. I put some numbers in red on the kind of left margin there. So we'll maybe jump through those one by one. So the first thing that comes back in the response is a transaction time. And so this is the date or the timestamp up to which the server is sending data. And this is useful. Remember that since parameter in the request. In your next request, you can use this transaction time as the start time for the new data set. So basically, this tells you when this data set runs until. And so when you make your next request, if you only want data that's been modified subsequently, you can use this timestamp in that request. The number 2 there, the request field, is just a reflection back of the request you made originally. That may actually be deprecated in a future version of the spec. Number 3 requires access token. So we haven't talked about authentication yet. We will in just a minute. But what this tells you is, or what this tells the client, is whether or not it needs to use that access token to access these data files, to pull down the actual FHIR data. In general, that's going to be true. In general, you'll have a value of true. In general, you'll need to use your access token to get the data. However, in the case of like an internal bulk data server, when you might be pulling data all within your network and putting it on an internal file store, potentially you wouldn't necessarily need an access token then to access it from your internal file store. So this was something that came up in some of the community work. And so we give the server the option of specifying whether it's going to require a token to access the data. And then the core part of this response is the output parameter. And so this is the actual files that contain your FHIR data in NDJSON format, as we discussed. And so each object in this array has a resource type. These are the FHIR resource types, and then a URL to access the file, a location for the file. And you'll notice here we have two files of patient resources. And so this highlights an important point, which is that servers have the option of splitting up the data into multiple files. So in this case, let's say patients were very verbose and the server was trying to keep file sizes roughly the same. It broke the patient resource and data into two files. Now, clients should be robust so that some servers may have a few very large files. Some servers may break things up into smaller files depending on how they're configured. And clients need to be able to kind of handle a bunch of these different situations. The one thing is to keep in mind is that though servers can have multiple files per resource type, they can only have one resource type per file. So each file is going to be a single FHIR resource type. And the reason for this is in the data load process, the client may want to treat different types of FHIR resources differently. So maybe doing a patient matching algorithm as it imports patient data, but not necessarily doing the same thing to add, let's say you want to add your institutional identifier to that patient resource. So you might want to do that only for the patient resources, but not for observation resources. And so you might want to treat them differently. And of course, you could filter them as you import them, but it's a little bit cleaner to have them in separate files. So here we have two patient files, one observation file. And then moving on to item 5 there's a key called error. This is a bit of a misnomer, and I think if we didn't want to break backward compatibility, we would rename it. It's really any type of operation outcome associated with the response. So that might be an error, but it also could be informational operation outcomes that are stored then in this NDJSON file. And you might be thinking, if the job failed, why would I get, these resource responses in addition to an error? And it's an option for servers. So if a server wants to fail the whole job, instead of giving a status complete response, it could give an error response with a single operation outcome. But in the case of a very large export, like where you're exporting data on millions of patients, potentially there are a few resources that might fail, but the server may not want to throw out the whole job because data failed for a couple patients. So having this error key gives the server the option of returning the data it can, but then also providing information to the client about whatever data elements within this data export failed and did not come through. So maybe data for a couple patients didn't come through, but the rest of the export came through regularly. So that's so the client can learn that by interrogating this file. So then the client can go and kind of pull down each of these files individually and review the FHIR resources in them. So I won't talk too much about FHIR resources. Hopefully, kind of at this point in DevDays, you've probably somewhat familiar with these FHIR data models. The one thing I do want to emphasize is that the bulk data API is a little bit agnostic as to which resources are returned from a particular server. So if the server is a server of a payor, it might have resources associated with claims. If it's an EHR, it might have resources associated with clinical data. So in the United States, a lot of FHIR servers support a data spec called the Common Clinical Data Set, which is required for certification, EHR certification for certain use cases, and that's going to be moving to something called USCDI. In any case, different servers will have different data that they return in response to a bulk data request of all data on the patient based on what data they have. So I think that's important to keep in mind. Also, in terms of FHIR version, the bulk data spec is kind of version agnostic, right? We're just returning FHIR resources. And so these resources, depending on the server or depending on the endpoint within a server, might be for different FHIR versions. So another thing to keep in mind as you read the specs for a particular bulk data export server is what resources it's going to be supplying back, and then what version of FHIR it'll be supporting. So I did want to talk a little bit about the NDJSON format. So if you're familiar with resources returned as JSON, for example, in a FHIR bundle, you would expect to see some of the syntax here that has the circle with a slash through it. So you'd expect your resources to be in an array with commas between them, and maybe that's encapsulated in a bundle with some metadata. And what NDJSON does is it strips out all that extra syntax, and it just has one resource per line. So the new line delimited JSON is one FHIR model, one FHIR object one FHIR resource object per row. And this is actually a pretty powerful distinction, even though it seems small, because what it means is that servers and clients can read and write these NDJSON files in a streaming way, because you don't need to know anything beyond one line in that file in order to process that single line. You don't have to load the entire file into memory to read it, and you don't have to have the entire file in memory to write it. So it turns into a pretty efficient way to work with FHIR data. The other thing is, even though it's fairly verbose, because you can see the field names are repeated a lot, because it's text and the FHIR Bulk Data API supports the use of gzip encoding, it compresses really well. So, so you don't necessarily have enormous files just because there are a lot of repeated fields. So kind of shifting gears, we've talked about a lot of kind of requests and responses. And in doing so, we haven't talked about authentication at all. Of course, in the real world, every bulk data server, certainly every bulk data server outside your firewall is going to be require some authorization, right? The client can't just make an HTTP request; it also has to provide an access token to be as part of that request in order to get the data. And so the Bulk Data API has a kind of a sister spec called Smart Backend Services Authorization, which is an OAuth-based public key method of authorizing the client requesting data from the server. And it starts with an out-of-band app registration. Oh, the other thing I should mention about this, in contrast to, for example, the Smart on FHIR spec, is that the backend services authorization, as you might guess from backend services, is designed for machine-to-machine communication. So in contrast to in contrast to the Smart API, where there's a user who has to log in at a certain place, this is, once it's set up, it can run as a job on a server without somebody having to intervene at all. And so it starts with kind of a registration step where the client registers, generates a public and private key pair, and then registers that public key with the bulk data server. And that can be registered as an actual key, or it can be registered as a URL that points to the key. If you're thinking about like business workflows, this might be the step where the server or the institution housing the server checks contracts to make sure that all the data use agreements are in place and that the party has the right to access the data. And then the server will provide a private client ID back to the bulk data client that it can use in requests. And what happens is that bulk data client signs a token request with its private key that the server then verifies with the public key when it wants to make a request, and gets back an access token it can use in the request. So that may sound a little bit complicated. It's actually not that complicated. We'll look at it kind of a flow in just a second. The last point I wanted to make about this is that if you're familiar with smart scopes for specifying access levels, those same scopes apply here, except instead of them being scoped to a user or a patient, they're scoped to the requesting system. So if we look visually at kind of that flow, there's that initial setup step where the backend service admin registers their public key with the bulk data server and gets back a client ID. And then when they're ready to make a request, they sign a token request using their public key, using their private key. The bulk data server verifies it using the public key, and then gives back a short-lived access token that the bulk data client can use in that series of requests for data that we went through before. So I know I'm running a little bit short on time, so I'm going to try to go a little bit faster through this part. There are a number of really good tools if you're building bulk data servers or clients. The Smart Reference Implementation Server is a bulk data server that's designed specifically for testing bulk data clients. So it's a configurable server. So you can do things like say, I want you to return 1 million patients in this request. I want you to return data for 1,000 patients. I want you to be slow. I want you to be fast. You can even have the server inject errors at different points in the process to make sure your client responds correctly to them. And it's open source, so you can either run it on the web or you can create a local instance and run it on your system. Smart also has an example client that you can use as a starting point if you're building a bulk data API client. And then a really cool tool that's funded by the United States government and is a collaboration between the Smart Health IT project and the MITRE Corporation, is a full test suite for bulk data servers. So if you're building a bulk data server and you want to make sure that you're properly meeting kind of all the intricacies of the spec, you can use this open source tool, either running it on the web or downloading and running a local copy to test out your server. I want to talk briefly about adoption, because mostly, even though we're kind of running low on time, because I think it's really exciting, a growing number of FHIR servers support the bulk data API, including Microsoft's open source .NET FHIR server, as well as their managed FHIR service in Azure. The popular open source Java Happy FHIR server supports bulk data export at the system level. The IBM open source FHIR server, also a Java server, supports the bulk data API, including pretty much all its features. I think it has really, really strong support. Carevolution has a commercial platform, commercial data analytics platform that supports the bulk data API. And then the Google Cloud Healthcare Cloud API has a bulk data support in preview. So that'll be coming out shortly for kind of public use, but it's in progress. A number of the EHR vendors are also participating in FHIR Connectathons in the bulk data track to kind of preview their bulk data implementations. So if you're interested in starting to develop with EHR bulk data implementations, participating in the FHIR Connectathon events in the bulk data track is a great way to do that. And then in terms of payor data servers, this is a little bit United States centric, but the federal payors in the United States, CMS, has a number of pilots where they're supplying data to different organizations using the bulk data API, including accountable care organizations, which are kind of care management groups that take on risk for patients. They're providing data at the point of care. So this is a pilot to do what I was talking about before, where you send claims data to clinicians so that they can get a 360-degree view of where patients are getting care outside of their system. And CMS recently launched a pilot for drug plans to be able to get clinical claims so that they can help guide a patient's medication usage based on their clinical diagnoses. So it's a really interesting pilot. And all of these are, some of these are moving, some of these are new, and then some of these are moving, include like the ACO one, from a proprietary format into FHIR and the bulk data format to make it easier for organizations to consume the data. And then lastly, Boston Children's Hospital has a neat prototype that combines clinical and claims data using obtained through the bulk data API in FHIR to do things like calculate quality measures. And that's an open source project that you can play with. I know this is the European version of DevDays, but I think it's important to look at one US regulation, which is a requirement for EHR certification that's going to require support for bulk data. So this doesn't go into effect until December 2022. It got pushed off a little bit because of COVID. But what this will mean is that many EHRs that sell into the US will at least have modules that support the bulk data API. So even if that's not included by default with your build of the EHR, it's a capability that these EHRs will have going forward. So I think that's pretty exciting in terms of creating an ecosystem of systems that support bulk data. So I know I'm running kind of short on time, but I did want to talk a little bit about the Argonaut project. So Argonaut is a FHIR accelerator. And one of the projects that we've been working on over the last year is putting some of the things we learned in version 1 of the spec into a version 1.5 of the implementation guide. So building some of that information into the spec. And one area I wanted to highlight is specifically around a problem with historical group data. So one of the things that came up in implementations is that if you're pulling data on a group of patients, for example, all patients who are affiliated with a particular payor, and a new patient moves into that group, that patient may only have data that's been modified since the last time you pulled data, or prior to the last time you pulled data. So if you do an _since request, you won't get necessarily that patient's historical data. Now you could request historical data on all patients in the group, just leave off that since parameter and get a full data set. But that might be many, many gigabytes of data that you don't really need. And so we want to have a way to get historical data only on the new patients added to a group, while still only getting modified data for other patients who are in that group. And so we address this in two ways. The first is that we loosen the language around what the server can return for _since. So in this case, we're saying if a patient moved into the group and their data is modified prior to the date you're requesting, the server can still send you their historical data for that patient or for those patients. And this is kind of fits with the bulk data philosophy, which is in general that servers may oversupply data and clients should be robust to being able to get data that they've already received before or that they may not need. And that works for systems that are able to track when patients move in and out of the group. But some systems, for example, let's say your bulk data server is doing a query to return all patients who are diabetic. It might not know who's been added to that group of patients since the last time a particular client requested data. And so we also added an optional patients parameter where clients can download a list of all the patients in the group to see who's a patient that they don't have historical data for, and then only request the full data set for those patients while requesting the modified only resources that have been modified for the other patients. There are a number of other improvements in 1.5. They're on the slides, and the draft spec URL was on the previous slide. So in the interest of time, I want to leave a few minutes for questions. I'm not going to go through these right now. But I wanted to close with a couple ways you can get involved in the bulk data work. I think one of the things, this is a pretty early stage spec. And so starting to do implementations and starting to use it in the real world and figure out what's working and what needs to be improved would be really helpful for the community. And it's also a good way to start moving more and more of your data use to FHIR. There's also an opportunity for open source modules that work with this bulk data exported data as part of a pipeline. So Microsoft has a really cool de-identification tool that runs on top of the ND-JSON files that would be exported from bulk data. So you can imagine a pipeline where you export the data from an EHR, you run it through the de-identification tools, and then you import it into a data warehouse or something like that. And I think there's opportunities for similar tools around validating data, filtering data, or even doing natural language processing on notes in data and pulling out some data into structured FHIR. There's been some very early work around standardizing how data is imported into systems in addition to exported out of systems. If you're interested in that, I suggest you jump on the FHIR Zulip chat, the bulk data Zulip chat, which I'll put up the link in just a minute. I think there's folks interested and trying to get kind of a community to coalesce who want to work on that. And then one area I'm interested in, and I put up a link to some initial work I've done in that area through the project called Sync for Science, is around taking this FHIR data and then doing analytics on it without converting it into another format first. So doing analytics on native FHIR data, potentially with some annotations. And so I'll close with that. I wanted to put up some resources. The bulk data implementation guide is there. The draft 1.5 link is on an earlier slide. The smart reference implementation I talked about is there. And then almost all of the work on the FHIR Bulk Data API happens or is coordinated through the FHIR chat at chat.phir.org on the bulk data stream. And then lastly, I put in my contact information, although I'll also try to follow up on comments or questions if we don't have time through Whova. So I think I'm mostly out of time. Do we have time for maybe 1 or 2 questions, Mark?
Yes, surely. Thanks, Dan. This has been a really good presentation. We do have some questions, and we do have about 5-6 minutes left, so ample time for questions, I think.
Great.
First question, very specific. Hi Dan, do you see FHIR Bulk Data as the first step in a US core to OMOP pipeline that could be standardized for research purposes? And do you see any limitations with such an approach?
No, I think that's actually a really excellent use case. So the question's around a format called OMOP, which is a really common analytics schema. And I know there's some work going on around converting FHIR data into OMOP. And I think having a standard export into FHIR from systems into FHIR bulk data and then having a bulk data to OMOP transform is a great way to do that. The other thing I think is really interesting is also starting to do some analytics, even if it's just data quality measures, directly on the FHIR prior to converting it to OMOP. So I think OMOP has had a lot of many years to kind of develop really great tooling around analytics, and I'd like to see some of that tooling migrate into native FHIR solutions so that when you have a set of bulk data exports, you don't necessarily have to convert it into other formats to do simple kind of cohort analysis or even just kind of data quality analysis prior to moving into OMOP. So it's a really good question. I think it's certainly a use case we want to support. And I also think there's opportunities to do some analytics even without converting it into OMOP.
Thank you. There's a question, and you partially answered that already in your slides. Is there a bulk data import standard too? So you mentioned that it's being developed. Can you tell us some more about the stage that it's in?
Yeah.
And when you expect maybe a first pilotable implementation?
Yeah, so I think the version 1.5 work on the core bulk data spec has kind of eclipsed or kind of pushed off some of the import work. So things are very early. So the URL there is for a very early draft of a spec. Certainly not something you would implement, but something you could start to think about how to improve or how to develop into something that would actually meet specific use cases. I think what we're really looking for on import is folks who want to kind of drive the development. So I think myself, certainly I'm interested, but I've been pulled a lot heavily into the bulk export 1.5 work and haven't really had time to devote to import. So if there are people who have specific use cases and want to really work on the spec, I encourage you to kind of jump on Zulip, post a note, jump on the FHIR chat, post a note, and try to get a group of people together to start talking about how to implement the spec. We'll also have a FHIR bulk data track at the FHIR Connectathon in January. And so potentially that we could have a breakout session if folks are interested to start thinking about kind of what the next steps are for an import operation. I will point out, though, that import's a little harder, I think, than export, in that there are a number of different use cases depending on why you're importing the data or what type of system you're importing the data into. I think we'll need to cover a lot of varied use cases, whereas export is maybe a little bit simpler in terms of use case because all you're doing is pulling data out of a system.
Yes. Quite some interest in the next question. Have you seen real-life examples of the use of bulk FHIR API for data registries? And if yes, can you share some insight on how the bulk FHIR API was used? So data registries, that's slightly different subject, I think.
Yeah, so there has been some very early discussion about potentially using bulk data exports and then sending them to a registry in kind of an NDJSON bulk data format. I'm not aware of kind of anyone who's implemented this in production or even kind of taken it very far, but I certainly think it's an interesting use case, you know, that could have really good applications. So, I mean, one workflow might even be doing a bulk export of data from an EHR, doing some filtering within the bulk data client, and then sending it to a registry with only the subset of data that's relevant to that registry. But that's not something I'm aware of anyone doing yet, although I think it would be a really good area for folks to start exploring.
Yes. Well, an obvious question is, what is the performance expectation for bulk data? How fast is it expected to be? And this, of course, is a difficult question to answer, but very important.
Yeah. I mean, I think it's going to depend a lot on the server. as kind of with any FHIR operation, the performance is really going to depend on, the system that's providing the data and how it works. But the expectation on bulk data is that it's not kind of an instantaneous export. So it's the type of thing where, you kick off a job and then it might take several hours even for a server to generate the data files for you to be able to pull them down. So the idea is, I think certainly performance matters, and you wouldn't want things to take days and days to process, but in contrast to kind of an HTTP service where, request response, where you're expecting kind of a kind of in-session quick response, with bulk data, since it's asynchronous, potentially servers could take a while, and then, you would check back and it would tell you, check back in a few hours, and then you'd be able to get the data. So I kind of see it more as the type of thing you would use in a scheduled job where your server regularly pulls the data on a schedule and that prior to when you need it. So that from a performance perspective, by the time you need the data, it should already be there, rather than kind of kicking off a bulk data export whenever you need the data. So I think it'll be interesting to see, as people do big implementations, what sort of performance characteristics they have, but hopefully because of the asynchronous nature, it shouldn't matter quite as much how fast the response times are on a particular request.
Well, thanks. We've run out of time. There are a few questions still popping up, but I'm sure you can answer them in the Wova app. So thanks again, Daniel. This has been a great presentation, and hope to see more of you in the next DevDays or working group meetings.
My pleasure, thanks. And feel free to reach out. I'll certainly look at the questions and try to answer them. But if folks have other questions, happy to have a conversation.
Everybody, thanks for attending.